So I would say we get started. I would like to welcome everyone to our architects presentation today, Passive House Traditional versus Modular, presented by Paul A. Castrucci Architects, who is focused on passive house design and involved in a lot of passive house buildings here in the city, specifically in modular buildings, which is great because not many architects have experience with that yet. I would like to thank Paul Castrucci Architects for your support throughout the years as a sponsor, which makes events such as today possible. So thanks for your support. It is my pleasure to welcome today's presenters, Grayson Jordan, who is a principal and partner at Castrucci Architects, and Ashok Chirunavukarasu, project manager and sustainable officer at Castrucci Architects. We will record the session and we'll make that recording available afterwards on our website nypassivehouse.org, and we will do a Q&A session at the end of the presentation, so please put all your questions into the chat box and we'll take them at the end. It's my pleasure to welcome Grayson and Ashok, and you guys can take it away. Thanks.
Great. Thank you, Andres. And thank you everyone for joining us this afternoon. My name is Ashok, and I'm here with Grayson, and we are from Paul A. Castrucci Architects. We are a full-service architectural and energy consulting firms, and we build to passive house design. So we're really excited about this talk about building affordable passive house buildings by looking at traditional versus modular project delivery. So in this presentation, we will do a detailed dive into 3 projects, Woodlawn Senior nearing completion, and Bethany Senior, which is about to start construction, and Habitat Net Zero. On a side note, we gave a similar presentation last year through New York Passive House, but here we're going to go into a lot more detail. So to frame our conversation, when we built a passive house, standard, it does meet local law 97 for the year 2050. And so passive house becomes a very cost-effective way to comply with the New York City local law 97. So here, what we see in the graphic is we use data from the city's annual energy benchmark report, as well as our in-house modeling on our existing projects. And what we find is that when we built to New York City Energy Conservation Code 2016, we're just meeting the 2030 target, but if we were to build it to passive house standard or renewable, then we're well within the 2050 local law 97 goal. So now I'll let Grayson talk a little bit more about our firm.
Yeah, thank you, Ashok, and thank you everyone for being here. It's a pleasure to present to you, and I thank you for your time. Yeah, as you stated, we're going to talk mainly about 3 projects, and it's about those projects are going to be centered around finding high quality and economy in affordable housing and passive house. But I just want to talk really quickly, frame the discussion about how we got here in our history with passive house, and start with our first passive house project from 2009. It was a 10,000 square foot art and activist community center located in Lower East Side for a group called ABC No Rio. The project is very much funded by grassroots and hodgepodge together, grassroots funding, a little bit of city funding. And that experience really impressed upon the firm the need to approach passive house really practically, to find ways to build economically, to build in ways that contractors are used to, and with materials that are easily found. So if we advance a couple of slides, fast forward about 5 or 6 years later, next slide if you can. And this is now 2015. We're implementing passive house in one form or another in all of our projects. Whether or not they are certified or not is another question. And we're finding that a lot of our clients are very receptive to the idea, but we still need to convince other ones. So this is R951. It's located in Brooklyn. It's an in-house development project, and really is a proof of concept about how we can build to a budget with passive house, but also how it's marketable on a market rate project. So this is a passive house certified, net zero certified row house. It did quite well. The marketing centered around the energy savings, of course, but also the quality of life, sort of best practice, occupant health, and air quality. Okay.
So here
Yep.
we're going to be presenting a couple of projects where we did retrofit in 2018. So in the photo, what we see here is 544 East 13th Street. This is an affordable co-op multifamily building. It's 6 floors with a basement. So even with our limited budget, we were able to apply the pass-cost methodology, and internally, we energy benchmark these buildings after a year of occupancy. So the good news for us is we compared our benchmark energy data for all 3 of these buildings to the city's annual benchmark report. And what we find is that for all 3 retrofitted buildings, it is in the top 5% in terms of their energy efficiency when comparing to existing buildings that are the same size and have the same occupancy. So Grayson will now introduce talk a little bit more about some of our current work and larger projects.
Yeah. So yeah, just highlighting what Ashok had talked about, we recognize that retrofitting existing buildings is a really important part of the puzzle in bringing high quality affordable housing and addressing getting to carbon neutrality. And it's also important to preserve the diversity of building types and ages in our communities. But in the city and the region, the housing crisis is such that we also need to build new. And many of our colleague architects are doing really, really good work in affordable housing, new construction, especially in bringing passive house to multifamily. And so we want to join that and support that effort and push. And that really the push is to make passive house the baseline. It's business as usual for affordable housing and multifamily in New York City. And so we've begun to put our efforts into working on those kinds of projects, and we're seeing them throughout the city, both in the ground and on the boards. If you go to the next slide, these are just a handful of things we have going on. Multifamily of different scales, ranging from 50,000 to 250,000 square feet, 60 units to 250 units. And that brings us to one of the projects we want to highlight today as a case study, which is Woodlawn. Woodlawn Senior is located in the Woodlawn neighborhood of the Bronx, very high up there. It's a 55,000 square foot, 4-story plus cellar, 80 unit affordable housing building slated for use by seniors. It's about 90% complete, and it will be certified by FIAS. Woodlawn is located in the Woodlawn neighborhood, as I said, which is across the street from the historic Woodlawn Cemetery and just east of Van Cortlandt Park. It's an R5 zoning district, so it's quite low scale, predominantly 1 and 2 family dwellings, but every block or two has a low or medium rise multifamily, of which Woodlawn will be part of that context. And I'll turn it over now to Ashok for a little bit deeper dive into this project. Great,
thank you, Grayson. So in the next few slides, we want to look at the envelope detail. So to help ensure that we get pass-pass level envelope and air tightness, we really work closely with the general contractors to hammer out all the detail. So what we're seeing here is the below-grade walls, which has 4 inches of rigid insulation. And then what we're seeing in the photo here is the waterproof membrane and air barrier that runs along the wall and wraps around the footing. Then what we have is the rigid insulation, and then there's a drainage plane on top of that. The photo on the right, this is showing the Baker air barrier, and the slab here would have about 2 inches of EPS insulation. So if we look at the exterior grade wall, what we spec'd for the project was either 3 inches of polyiso or 6 inches of EPS that runs continuously. So that's between R20 to R22.5. So here on top, we see the exterior shell, which is 8 inches of CMU concrete. And then what we have is our primary air barrier, which is the liquid applied stow, and then 6 inches of EPIS, and finally, there is a stucco finish. So there is no interior insulation, but on the inside, it is furred out. But the way we have it here, it allows us to minimize a lot of our thermal bridges and give us a lot of clean details. If we look at the roof, what we spec is about an average of 7 inches of polyiso, which is about an R45 placed above a concrete plank roof. And you can see here how the parapet detail is treated. What you're seeing here is 4 inches of EFIS on either side of the CMU. You can't quite see the CMU because you got the wood blocking, and then you have the air barrier, and it will be a continuous metal coping around the parapet. If we look at the windows, what we did was we spec triple pane windows. The details here show how we achieve the passive house air level air tightness. So to what we have, the primary air barrier is on the exterior, and we make sure on the exterior everything is taped to make sure the air barrier is continuous. Additionally, what we have is a secondary air barrier. So we have our wood blocking, and then we wrap our stow air and waterproofing into the wood blocking, and then we place a window in it. And then around the window, we caulk it all around the edges. And finally, we use the interior air sealing tape all around. So what we found when we did the mock-up on the window is that in terms of the blower door testing, we did really, really well. So one of the things that we're really curious about in our next project is if we need all the sort of interior taping. So we're going to try that with our mock-ups next time with our project. So just to present briefly some of the MEP system in this project. So we have a VRF system. The outdoor units are located on the rooftop. So you can see that in the forefront of this photo, there is also a cooling unit, which is just for the trash room. The project uses a natural gas-fired water heater for the domestic hot water, which is located in the bulkhead of the roof. And then we also have 4 central ERVs placed on the roof. So ERV 1 through 3 are continuous, while ERV 4 is time scheduled. And ERV 1 and 2 are serving the apartment units. 3 is for the corridor and utility room. And finally, the 4th one is the time schedule that serves the common spaces in the cellar. So next, Grayson will talk a little bit more about some of the challenges with affordable passive house housing.
Yeah, thanks, Ashok. I am seeing some questions in the chat that are interesting, and we'll circle back to those. But just sort of broadly speaking, so the front of Woodlawn EFIS is actually a Woodlawn is actually 10 inches of EFIS, and that is only because we wanted to chamfer out those windows, and that was one of the questions in the cut. And EFIS is something that can easily be sculpted with those chamfers. Woodlawn Senior is about done. It's been a successful project. It's on budget. It's on schedule. We're going to be passive house certified. But we're always looking, especially in affordable housing, you are kind of hemmed in with the budget. So we're looking for creative ways to get more into our buildings. And so just thinking about affordable housing and passive house, affordable housing construction is really well defined. It's almost always block and plank construction, often with brick facades. And there's a lot of really good work in that typology, but there are limitations. I mean, there are budget limitations, of course, primarily by labor cost in senior housing. You're married to that construction typology, which is going to and to sort of set some materiality, but also formal constraints. And as buildings scale up, there's a concern about quality assurance. We always do mock-ups, we do kickoff training sessions, and lots of testing and inspections. But as we scale the buildings, you see less and less of the detail work. So the mock-up may be perfect, but as the 35th or 50th or 100th window gets installed and maybe the guy's tired or cold, it doesn't get put in quite as well. And so we're looking for ways to sort of overcome that challenge. And one of the things we're exploring is modular construction. And so just to define what we're talking about in modular in this discussion is a box that has four sides, a roof and a floor. That interior of that box will be completely completed. So your finishes are done, your kitchens and bathrooms are in, lighting, all that stuff is in. It's all built in the factory. It gets put on a truck, shipped to the site, and stacked up amongst other boxes. And if we could advance it one slide, Ashok, that's in contrast to prefab, which is also something we are exploring in the office and really promising. But that prefab is more of a flat pack, prefabricated wall panels or floor panels. And I think that's an area that has a lot of promise. It's just sort of outside of what we're talking about today. So in thinking about modular, what we're thinking about is, first of all, again, why are we doing it? And the major reasons are cost control, reducing schedule. We think that we can reduce schedule by 25 to 30% in quality control. And then on the other hand, what are the additional design considerations that we have to review? And those I'll talk about in more detail, but are broadly, the mods themselves have size limitations that you have to plan for. They have height limitations that you have to plan for. So you're going to have a thicker floor line and ceiling in each mod, so that's thicker than block and plank. You have to plan for the stacking of the mods and the transportation. How you implement MEP solutions is going to be quite different, and the testing protocols are going to be a bit different. So that brings us, I think, to the next slide, Ashok, which is our first of two modular projects. This is Bethany Senior, again, another affordable housing building for seniors. This is located in Brooklyn. It's going to be a 59-unit affordable housing project in the East Flatbush neighborhood of Brooklyn. It's 45,000 square feet. It's going to be FIA certified and has about a 130 kilowatt solar array on the roof. Looking at Bethany, similar to Woodlawn, it's an R4 zoning district. So we have predominantly low-rise 1 and 2 family dwellings in the neighborhood. This is replacing a similarly sized building, institutional building. So we're replacing in kind contextually. A big draw for us in looking at modular as a way to control cost is the ability to get some of our other architectural ideas in there. So the more passive house we can do at the better price point, the more we can get these ideas about creating really dynamic social spaces, creating spaces that encourage activity, and creating indoor-outdoor connections between interior common spaces and really nice exterior gardens. And that's what these conceptual diagrams are showing. Next slide. And here's a sort of a section perspective through our lobby to the south. And what you're seeing here is lobby and community rooms are located along the south of the building, and they're going to open up to gardens and terraces that allow for circulation from our cellar community room, which actually opens up on grade to a sunken garden through a series of steps and terraces all the way up to our top floor and another community room up there. And there's a real emphasis on the quality of the interior spaces, light-filled, warm, connection to the outside, but also providing a diversity of kinds of social spaces for meeting in large groups and down to more private recreation, which I think is always important and has been sort of underscored during COVID. Okay, here we're looking at the south, sort of showing those terracing southern terraces. So in thinking about approaching modular, one of the first things we're going to do is think about transportation and how we're getting mods from the factory to the site. So we're going to map out a route from the factory to the site, and that's going to tell us if there are any additional physical dimensional restrictions on our mods beyond what can be built and typically shipped. So if there are low bridges or tunnels that might restrict us a bit more in our mods, so we'll map that out. And then on the site itself, we want to map out where are we stacking our mods, where are we putting our cranes, and what that process is like. And Bethany turned out to be a great project to start with that because it has lots of yards, lots of space for staging, et cetera. The next step is to think about, what's modular, what's site built. That is pretty straightforward for Bethany. Everything below grade is site built. Almost everything above grade is factory built. There's a few spaces on the first floor that are site built just because they have unique spans. And in discussions with the contractor, they felt they would be more economical to build those in the field. But then for the most part, we're trying to push as much as we can to the factory to control cost and schedule. MEP is done quite differently between Woodlawn and Bethany. So as Ashok described, Woodlawn had a centralized ERV system which works quite well. It reduces maintenance, but it does have a lot of sort of branch ductworks for ventilation. For Bethany, to reduce those branch ductworks, but also to lean into what modular is, we have individualized ERVs in each unit. And that allows us to deliver a completed ventilation system to the site, built completely in the factory. There are maintenance trade-offs for that. You do need to get into the units to maintain the ERVs, but for this specific client and the types of residents that will be here, that actually made sense. It was a benefit because they're wanting to check in to these spaces and coming every month or so, every couple of months to look at the ERV is just another reason to check in on the residents. The way that the MEP is integrated in modular is a bit different than typical. So typical construction, you might stack your bathrooms back to back, share your plumbing pipes. Here we want to align everything to the hallway. So all of the plumbing, sprinkler, electric is going to be in the hallway walls, built in the factory. And then when it's stacked up, that's all left open for the site contractor to come and make all the connections and finish back over. This building is, last thing I'll just say on the electric MEP is that it's a fully electrified building. So we're using heat pump hot water heaters. We've looked at a couple of different approaches to that. This one is uses 4 hydro kits in our roof mechanical room connected to exterior condensers. It has storage tanks to reduce the peak load and electric reheat when needed. It will use 20% less energy than gas. We also explored a heat exchange configuration, but that precluded the use of refrigerant monitoring, and we're starting to get more into trying to, first of all, provide an option for landlord building, but also get user feedback on a more granular level. This is a typical wall section showing delineating what site and factory built. So blue is going to be factory. So that same decision you make in the big picture planning, you make at the detail level, what's going to be built in the factory and what's going to be built in the field. You could build theoretically the entire thing in factory. Here we've decided in consultation with the GC to stop the factory work at the structural sheathing. So we're going to get a structural sheathing in, we'll get our primary air barrier in, we'll get all of our windows in. Those will be air sealed to the air barrier. And then in the field, after the mods are stacked, you have to heal all the edges of the mod. So each mod will have 4, a top, a bottom, and 2 sides that sits on other mods and connects to other mods. That has to be air sealed to each other. And just because on this job, they are planning to scaffold the whole building anyway, it made more sense for them to then do the finish as well. Here's just a more zoomed in look at the window detail. So modular construction, broadly speaking, is for this job is steel construction. So you have steel beams and you have steel posts at the corners and some intermittent points, and within that is metal studs. So it's basically a 4-inch metal stud, a triple pane window, and then we're going to have continuous insulation on the outside of that sort of frames over the windows a bit. And then our air sealing is on that structural sheathing plane, a really simple tape straight from that sheathing and air barrier to the window all around detail. Here we're looking at the roof. I think I mentioned that we have a pretty big solar array on the roof, and we're lifting that up so for FDNY access and also for resident access. And so there's a lot of sort of steel points of connection to the roof. And to thermally break that, we're just using sort of in the middle there, you can see an Armortherm thermal break that we're bolting through. And of course, we've therm modeled each of those as part of our FIAS certification. I think that sort of wraps up a brief discussion of Bethany. And so I'll hand it back to you, Ashok, to look at Habitat.
Great. Thank you, Grayson. So Habitat Net Zero, it's an initiative by NYCHA Next Generation. These are small single-family or 2-family homes, and they will be built to FAST standards, but not certified. So to give some context, the city of New York sought to develop energy efficient, small, affordable homes on many of the foreclosed homes and lots from the 2008 recession. So this project represents sort of the first wave where we're trying to develop 13 sites, and they're spread all across Queens. So here are some of the images showing the existing conditions of these homes. So one of the interesting things is that there are many factors to consider here. So for example, the site orientation, the topography, each site has different areas, different zoning regulations, transportation, crane access. So as designers, we really look to find commonalities between all these sites and propose sort of a prototype. So a significant goal for us here is to sort of create a methodology to build healthy, energy efficient homes where families can thrive, but at a price point that is very affordable. And so the project scalability, especially on a citywide basis, is a very critical success metric for us. So we engage early with the general contractor to investigate these homes, looking at site build construction. But we also spoke to a dozen or so panel and modular companies across the US. And it wasn't surprising, but what we found is that the more that the building is built in the factory, the lower the price per square feet. So other factors that impact the cost is transportations of the module. And one of our, so for example, in some of these projects, because of trees and the way the buildings are located, it kind of makes the transportation logistics way more complicated. And this really drives up the cost. And so we had to kind of work around that. What we have is what we really try to do is create the minimum number of prototypes. And we also use the solar to kind of create an architectural profile. And another thing we wanted to consider was sort of create this indoor-outdoor connection to help increase the sort of living space. So through this, we built 4 prototypes, and these are based on the site orientation, lot size, zoning regulation, energy, and the spatial layout for all 4 of these prototypes are very similar. So some of the core principles we have is trying to optimize the space to provide the maximum number of bedrooms allowed by code. Again, we placed the living space in the rear and connected it to the backyard to open up the space and provide this link between the interior and exterior. And we also have this concept called the flex room, where we're designing sort of a dining room or a den, but it can be converted into a bedroom to allow families to age in place. So this slide shows how the mods come together on the site. So basically, the general contractor will first build the foundation on site, then the first mod would be craned in, and the second mod, and then we would have a modular solar parapet and solar panels that's also craned into place. Finally, the contractor will come along, build the stairs, patio, and do some air sealing as well. These are the 4 final prototypes. We have here type A, which is the first prototype. All of our prototype has living room in the rear and connection to the yard. Prototype A is meant for lot size that are between 25 to 30 feet, and it has 4 bedrooms. So our prototype B1 is our narrowest lot, and it's about 20 feet, and it has about 3 bedrooms. So on 3 of our site, we were able to have 2 family homes, and they're basically 2 B1 types next to each other. And finally, we have our smallest lot type, which is our type C, and it has 2 bedrooms. And these are our smallest, and it was governed, the size was governed by the zoning. If we were to look at the detail, this is very similar to Bethany, where we have much thicker floors. So the cladding and exterior insulation are factory installed. What we want to focus here is also the mate line detail. It's very critical because this is where we have to ensure the continuity of insulation and air pressure. So we have the double floor plate between the first and second floor, and what we did was about 1 foot around the mate line would not have insulation. So once the 2 mods are craned into place, the general contractor will go around to ensure that the air barrier and the weather barrier are continuous, and then put the installation and the finish. So the home is wrapped with about 3 inches of polyiso, except for the roof where we have a little bit more insulation. And where we have our thermal bridge is really where the mods will connect to the foundation. But we use armored therm to reduce that thermal bridging. As we start looking into these projects, we start thinking about carbon emission through the life cycle. And since carbon emission is a critical metric for us, it's important to note that we don't really have the full picture on modular for Bethany Senior, but we looked at a study to start having this conversation. So there would be some material savings through modular, but when it comes to Bethany Senior, we're also using a lot more steel. So that's where we're not completely sure. But when we look at carbon emission during the construction process, we can measure that based on the transportation of materials, the equipment used on site, and the electricity used on site. So what we did here was we looked at a 50-year life cycle. And what we find is that based on some literature review, as well as some energy modeling we did in-house, the operational carbon reduces from about 50% from code build to about 30% when we do passive house. So we have room to further reduce our carbon emission. And this is where we want to start investigating the embodied carbon. So what we did is our study uses the embodied carbon calculator, the EC3, and we looked at 3 different types of materials: the insulation, the concrete, and steel. And we studied how much carbon we could reduce by considering materials that have lower embodied carbon. So, you know, we're just looking at the typical materials that's being used in projects, and then we're substituting that with other materials that would have lower embodied carbon. So when we look at the life cycle, a 50-year life cycle, and we compare going from New York City Energy Conservation Code 2016 to FIS 2018, we see a 40% carbon emission reduction from baseline. But then when we start looking at the embodied carbon and just looking at these 3 materials, we could further reduce the carbon emission by 20 more percent. So I think, especially in the context of local law 97, I think this is really important to look at embodied carbon, because, you know, when it comes to operational carbon, we could always reduce it throughout the life cycle of the building. But once we build the building or retrofit the building, we can't reduce that embodied carbon. So Grayson now will talk about other initiatives we are taking in our firm to further reduce energy and carbon emission for buildings.
Yeah, thank you, Ashok. Yeah, just to wrap up, we're always looking for better ways to do this work, and also to make better buildings and to drive down energy. And so just for the purposes of conversation, talk about a couple of initiatives like embodied carbon that we're just now sort of embarking on. And so we don't really know where this ends up, but it's just what we're thinking about. And one is, how do we, in these, after we've driven down all of our energy use as best we can through the thermal envelope solutions and MEP solutions, that next big thing is the user. And how do we, you have very little control over it, but we're starting to at least try to understand how things are being used. So we're pushing to get as much granular monitoring as we can, both on the water and the electric side. Hopefully per circuit, and that does a couple things. I mean, you can first of all, you can find outliers. So if something's wrong, you can identify it and fix it, which is important. But the hope is that it will help us understand how users are using the building in ways we can make it better and drive energy use down. And we're also exploring, beginning, or at least to talk about ways to put that into a feedback loop where somehow what the residents are using, they understand it, and they're able to that gets fed back to them in a way that hopefully influences their use patterns. Yeah, I think that pretty much sums up this presentation for today. Um, we're really happy to present to everybody and hope to take some questions.
Yeah, thanks guys for the great presentation. We have a lot of questions here regarding the Woodlawn senior building, specifically the angle cuts of your facade. So a couple
Yeah.
of questions there. How did the cuts, how did you do them? Which how did you address durability of the ephes corners?
Yeah.
And for example, did you cut them on site or prefab those?
Yeah. Yeah. So those cuts are just on the front facade. And what we did there was we bulked up the ephes to be a bit thicker to allow for that cut to have some aesthetic effect. And yeah, so everywhere you see that is pre-wrapped. All those cuts is pre-wrapped. I forget the exact product but with a more durable sort of mesh for at those chamfers, so to address the durability issue. They are done in the field. I think they probably could be done elsewhere, but you know, it certainly took a little longer than typical, but it wasn't a big driver of schedule or cost to do it in the field. We just did the mock-up, signed off on the way they were doing it, and they did, by hand, a pretty good job.
And how did you guys come up with the color for the building?
The color is pulled from some buildings in the neighborhood.
So it's not the brownstone kind of a color. It's similar a little bit, right?
No, yeah, and then actually in this presentation, I noticed that the color reads really differently. I think some of the shots were from a drone, and the color correction on that is quite off. But yeah, it was pulled from some of the masonry buildings in the neighborhood.
And how did you guys address the potential overheating of the building? Do you have inside blinds or any shading system?
Yeah. So yeah, we had the only, so that south facade does have the thicker ephes. So at the top there is a bit more shading, but primarily through white reflective interior blinds.
On the inside.
On the inside. Mm-hmm.
Okay. And going to the next building, I think Tom has a question regarding where did you get the modular passive house modules built?
Mm-hmm. I mean, yeah, I don't think, I think on the prefab side, there are a lot of really good builders who are focusing on passive house, and GoLogic and Build Smart are two that come to mind. But on the modular side, it's just a standard modular company, and we just told them how to build it. So we gave them, they'll build the spec. So just like a GC, they aren't specializing in passive house, but the hope is that you keep it simple enough that that it's not an issue for them, and that I think is the case here. It's pretty close to conventional construction, a bit more insulation and a bit more detail paid to the air sealing, better windows. Yeah.
Can you tell us who the manufacturer is, or?
Oh yeah, sorry. That's Whitley. Whitley manufactured for Bethany, and then for the Habitat, it's even though it's a wood stud building, they're called Modular Steel Systems. So they do both steel and wood stud.
And I guess from that map, they come out of Brooklyn.
Yeah, so the one in Brooklyn is Whitley, which has done quite a number of modular buildings in the region.
And Suzanne asks if those modules are assembled in the facility.
Yeah, so the modules themselves are completely, so what you get delivered to the site is, there's some flexibility, but for this project, what you get to deliver to the site is it's from front to back, front wall to rear wall, 15 feet wide, 10 feet tall. The apartments are completely finished. So, the idea is that you lock the door when you deliver it. The site contractor shouldn't have to walk into the apartments at all. And in this case, we left the exterior finish off. So the windows are in, the structural sheathing's in, the air barrier's in, they get stacked up. And then the site contractor comes and heals the air barrier around between the boxes. So he air seals between the boxes and puts the finish on. It actually also has to extend the intake and outtake of the ERVs past that finish plate.
So the contractor who puts them together is different than the manufacturer itself.
Yes, yeah, and that's any contractor you're comfortable with. I mean, they have to be somebody who can manage logistics, which most good contractors can do, and that's really the only the only criteria. They don't get certified or anything. You have to be comfortable with their ability to deliver a product that's a little bit different than the typical methodology.
Mm-hmm. And so there are a couple of questions regarding the materials used for both the prefab and also the EFIS building. So one question by Rob is, how sustainable are the materials used for the construction of the prefab panels? Oh, that's not panels, it's modules, right?
I don't know if I saw that. I don't know if that's about the Trimco. So that those prefab panels were Trimco that we showed in the presentation. And they are doing some good work in energy efficient prefab panels. Yeah, I mean, I think with all these things you can specify. I don't know where that question is going, whether it's embodied carbon. I assume it is. You can specify it, but there's always there's cost and durability concerns. I mean, you have to thread the needle for yourself about energy performance, durability, embodied carbon. They all matter, and we got to find the right balance for the project in the budget.
I mean, do you guys have you did the carbon calculation for your buildings, and one question Kevin has about the very high embodied energy of EFIS and brick.
Yeah, well, it's not neither of them are brick. Yeah, we want to get away from we want to reduce carbon. I think mainly the big chunk though is the structural frame. But both buildings we showed have our high embodied carbon. You have concrete and concrete block for Woodlawn, and that's how almost all affordable housing is built. And you can change the concrete spec a little bit, but it's high embodied carbon, but so is metal. And so it's not something we have an answer for. It's something we're thinking about. I mean, it would be wonderful if we could somehow get CLT into the conversation. It's a bit tricky from a cost perspective, and also I think still from a New York City code perspective, I'm not sure that they've quite classified that as mass timber yet. I haven't done a CLT building, so I could be wrong on that.
And have you guys looked into alternatives to the EFIS? Like cork or rock wool has a system as well.
Yeah, for sure. I think to the extent that we continue doing EFIS buildings, we're going to see probably a rock wool EFIS building as it becomes more available from the primary companies in the U.S. I don't think it was available from Stowe, which is what we used for Woodlawn when we specified it. But I think it is available now.
Mm-hmm. But I guess there's a cost difference right between those EFIS systems.
Yeah, we haven't specified it yet, so I don't know. And I honestly don't think that mineral wool is that much better from an embodied carbon perspective than the EPS, to be honest.
Well, it can be recycled, so that would be an aspect to be followed.
Yeah, true.
Mark has a question regarding the size of those modules and at what point they become cost effective. 10,000, 20,000. You have done small buildings, right, and larger buildings.
Well, yeah, I mean, I think it depends on what your baseline cost is. I gather we have people from outside of the city here, so I think the economics of building in the city are really different. That's part of it. So I think I don't know that we can say this definitively, but you could make the case that building something outside of New York City is always more cost effective than building in New York City. I don't know that you can say that categorically, but you're close to being able to say that. But I think for us, the cost driver was more like, what are you paying for labor? So for Bethany and Woodlawn, it's prevailing wage, which is typically $450 to $500 a square foot, and as opposed to a standard construction job, you might be trying to get $250 to $300. So that labor rate is a big driver of cost. Mm-hmm. And so I think regardless of the size of your building, it's competitive.
Mhm.
So I think somebody like Whitley, though, were on the smaller end of their jobs. So that 45,000 square feet, they might want a little bigger. Um, so maybe more in the 100,000 square foot range, typically.
And for the habitat building, that would be then a different modular builders, or?
Yeah, they're a smaller builder who actually I think did a lot of work and built it back after Sandy. So a lot of single family homes, and yeah, that they're much more appropriate for a single or two family typology in their factory.
And there's a great question by Christian. For each living unit, have you looked at the minute air units? So a combined ERV heating cooling system.
So for Habitat, we did look at a combined heat pump ARV system, but what we found out was that the sort of the air requirement for the ERV just wasn't enough to meet the heating demand. So if we were to go with that system, we would have to have like some sort of supplementary system, and I think that kind of defeat the purpose, and so we kind of didn't go with that system.
And there's one question regarding approval of those modular buildings. On your experience, what are the challenges and opportunities to get those buildings approved through DOB?
That's a great question. We had that in our last presentation and cut it out. Yeah, so and the two buildings we showed are good case studies because they show the two different ways that you get approved in New York City. So the short answer is I don't think it's been really any harder. There's an extra step for both buildings. For a larger scale, so anything I think above two family, you go through OITCR, I think is the acronym. It's basically like DOB's wing for sort of odd technical designs. And they've, in the last 10 years, really ramped up pretty well in dealing with modular. And so you basically fill out a couple of extra applications, send them your plans. And I think they're really more about looking at who's doing the building. So partnering with somebody like Whitley, who's experienced and known, made that process really pretty simple. And we got that approval way before our zoning was approved. So that was not an issue at all. On and then you have to hire inspectors for the factory. That's another part of it. So the inspection obviously is a bit different. You have to hire a suite of local inspectors to do those on factory inspections that you would normally do in the field. For the smaller, it gets approved by the state, and that does take a bit longer. So two families and below they almost look at it like a product, like the building as a product. It's like a fancy like window, let's say, except it's more components. And so that all gets approved at the state level with really detailed completed drawings, essentially. And we're in that process now for Habitat. And so that does, and for us, we didn't want to do that until we were really through the zoning, because we didn't want to, because you get the state approval. If you change something, you have to do it again. And so it does add 6 to 8 weeks to the approval time. And
how long is that approval process for the state, roughly?
About 6 to 8 weeks.
Oh, I see. That's still fairly good for a complex product, right? You get approved.
Yeah, for sure. Yep.
One question regarding the size of the modules. You said 10 by 50, or what's the max size of those modules? And what limits your size, kind of?
Yeah, that's a good question. I'm realizing that I really blew through a lot of this stuff. I apologize. I should have covered this. Yeah, it depends on your site and the route that you take to get there. That can limit it, but broadly speaking, it's about a little bit more than 14 feet. So I think the biggest we can get was 14.6 wide, about 11.4 tall, and 60 feet deep. And that 60 feet really does, I mean, that modulates, you're not going above it as far as I know, or as far as I've been told on the projects we've done, but you might have to go under it depending on logistics at the site, what you can maneuver there, if that makes sense. Like you got to swing it around and get it in place amongst whatever else is there, power lines or whatever.
So I would like to thank everyone for listening in. It was very great presentation. Thanks guys for presenting, and thanks for doing that great work. It's really astonishing what you guys do.
Thank you. Thanks everybody for the great questions.
Thank you.
Thanks for having us.
Okay. Thanks everyone.
Bye-bye.